Good morning, class. If you see Marshmallow Man behind me, start to make a move. Please yell. So today we're continuing along with our introduction to the file system interface. Today's topics are file system mounting, file sharing, and file protection. And here, one last time, are the chapter objectives. Here we have one mounted file system mounted as at slash. This is an unmounted file system, which momentarily, this is the root here of the unmounted file system, which is about to be mounted, as you'll see in the next slide here at users. Note these directories underneath users. After the mount, these directories will disappear. So here's the file system after the mount, and as I just noted, the original files that were under here are removed. That's typical with Linux. Whatever is at the mount point within the original file system is no longer visible. I think I remember reading once upon a time that one of the options in design is to merge the file systems, but actually I've never seen that in practice. I don't know if that's an option available with the mount command in Linux or not. So file sharing can be useful. Here in Julia Rogers, for instance, the XLab workstations will dual boot into Linux, and so that students who have accounts on those systems can access their files from any of those workstations. Their home directories are actually kept on Phoenix, so that home directory on Phoenix is exported and then mounted within the client file systems. There have to be some protections in place so that user can't can't access those files on the server as for instance root. There has to be some synchronization between the systems so that the user IDs match between accounts as well as group IDs. And finally, as mentioned here, the protocol that's used in Linux, or the specific protocol that I'm using right now is NFS. All right, so files can be shared manually using FTP, the file transfer protocol, or its secure version, SFTP, which is related to SSH. Obviously, you have to log in and change directories and use get and put commands to share files. That's not very convenient. Mounting a remote file system is a lot more convenient. You're not even aware most of the time that that you've mounted a remote file system. NFS uses a client-server model. Phoenix in the example I described is the NFS server. The XLab workstations are NFS clients. This is very true. There are a lot of holes in NFS security. So for security reasons, I try to restrict what the IP addresses of the NFS clients, but as anyone who understands networking knows, if you take down one of the clients, you can certainly reattach to the network using your own machine on that IP address. This is the, as mentioned here, the standard Windows protocol. That's what provides your G network drive. Interestingly, Windows doesn't do mounts into the mounted file system. So rather than having a single tree for the file system, Windows, as you probably know, has a forest of trees. And then going along with NFS, there's an associated need for sharing meta information for a system, the password file and the group file. For the XLab workstations, I'm using Network Information Services, NIS, sometimes referred to as YP or Yellow Pages, and again, that's not a particularly secure protocol. So there are a number of strategies that one can use in preventing failure or the corruption of metadata or recovering from it. On the prevention side, I'm thinking of such things as a log-based file system or the use of stable storage, as we've discussed in the past. If the metadata should get corrupted, there are additional strategies, of course the worst of which is recovering from a backup. But other strategies include such things as keeping copies of the metadata, as mentioned here, with respect to remote file access. The network adds its own set of problems, including routers going down and that sort of thing. So I'd say the main thing here is with remote file systems, we now have to think about if multiple clients have a file open and a write occurs, when does that write become visible? Does it become visible immediately, or meaning that there's in some sense a single global version of the file, or is its visibility delayed, meaning in some sense there are multiple local copies of the file? So moving on to file protection, the owner, which is typically the creator of a file, should be able to specify what can be done and by whom. These are the types of accesses we could consider. Linux only uses read, write, and execute. Append, delete, list are considered to be subcases of these three main cases. So Linux has three access modes: read, write, execute, and then breaks the users into three categories. The owner, in this case, so the owner permissions are the octal number 7, which breaks down to read, write, and execute. Notice that octal 7 is binary 111. The group of the file, here the permission is 6, which in octal, converting it to binary is 110, and then public, or I tend to call this world, which has permission 1, which is just the execute permission. So when a file is created, it's assigned, the creator is the owner, and then the creator's default group is attached as the group of the file. So for instance, on Phoenix, students are assigned to the student group, faculty are assigned to the faculty group, so I can create a file and give access to it to other faculty via the group mechanism, and then give access to everyone else, students for example, through the world permissions. So these are the traditional Linux/Unix permissions. Modern versions of Linux have more flexible and more powerful, and perhaps a little more difficult to use access control lists as well, which can be access control lists can be used when the file system is mounted by including an ACL flag when mounting the file system. So here in passing is how access control lists can be managed in Windows 7. So here's what you'll see if you perform an ls-l from a shell in Linux. So here are the permissions. The first three are for the owner, the next three are for the group, and the final three are for world. This is the username of the owner. This is the group name of the group. Size of the file, last write date, name of the file, and I believe, if I recall correctly, this column is for the number of links to the inode. Right, and that completes chapter 11.